Hello kids, the topic which we are going to discuss today is geometric progression. Let us discuss briefly some of the properties of geometric progression. Listen here, you are given a sequence an, which follows a geometric progression. Then common ratio R is given by A2 by A1 equal to A3 by A2 equal to A4 divided by A3, etc. Look, A2 by A1 implies A1 not equal to 0, A2 not equal to 0, etc. What does it mean? No term of a geometric progression can be 0. Since A1 not equal to 0, A2 not equal to 0, etc., etc., common ratio of the geometric progression are also not equal to 0. Now, sum to n terms of a geometric progression is given by the formula a into r power n minus 1 divided by r minus 1, r not equal to 1, because when r equal to 1, this formula it reduces to 0 by 0 form, which is an indeterminate form. What happens if r equal to 1? Let us see what happens to the sequence when r equal to 1. GP is there, first term is a. Common ratio 1, what will be the next term? AR, again A. Third term, AR square, A, etc. A, how many times? N times. So, sum to n terms is equal to n times A when R equal to 1, when common ratio equal to 1. A1, A2, etc. An is a geometric progression. We have seen that common ratio are not equal to 0. What happens to the sequence if common ratio r is greater than 1? If common ratio r is greater than 1, this sequence will be an increasing sequence. Increasing sequence when the common ratio r is greater than 1. R equal to 1, already we have discussed, when r equal to 1, the sequence is a, etc., or we say it is a constant sequence. It will be a constant sequence if common ratio r is equal to 1. 0 less than r less than 1. That means if r lies between 0 and 1, sequence will be a decreasing sequence. The sequence will be a decreasing sequence, and for all values of r which are less than 0, that means r is a negative number. I am taking an example, let r equal to minus 2, and first term I am taking it as 1. What will be the next term? Minus 2, next 4, minus 8, etc. Alternate, the terms are positive and negative. So, neither we can say it is an increasing sequence, nor we can say the sequence is a decreasing sequence. So, we cannot say anything about the sequence if the common ratio r is less than 0. Clear? Now, let us discuss geometric mean. Geometric mean. Geometric mean. Let a and b be two numbers, then the geometric mean between these two numbers is defined as under root of AB. Under root of AB, or we write it as AB power 1 by 2. Suppose we have three numbers ABC, then their geometric mean is ABC, product ABC power 1 by 3, etc. Consider the numbers 2, 2 power 2, 2 power 3, etc. up to 2 power n. Can you find the geometric mean of these numbers? Look, 2 power 1, 2 power 2, 2 power 3, etc. 2 power n. How many numbers are there? How many terms are there? 1, 2, 3, 4, etc. n terms are there. So, geometric mean will be the product of these numbers 2 into 2 square into 2 cube, etc. up to 2 power n whole power 1 by n, which simplifies to 2 power 1 plus 2 plus 3 plus etc. up to n whole power 1 by n equal to 2 power sum of first n natural numbers, which is n into n plus 1 divided by 2 whole power 1 by n and n will cancel off to give you the geometric mean as 2 power n plus 1 divided by 2. Right? Again, proceeding further, we have seen that sum to n terms of a GP is given by a into r power n minus 1 divided by r minus 1. Let us rewrite this formula. I am going to multiply it. A into r power n divided by r minus 1 minus a divided by r minus 1. I have just opened the bracket. It is Sn. Can you say what happens to this Sn when n tends to infinity? In fact, two possibilities are there. If the common ratio r is greater than 1 or if the common ratio r lies between 0 and 1. If r is greater than 1, write a sequence, consider a sequence with common ratio equal to 2. 1, 2, 2 square, 2 cube, etc. When you find sum to infinity of the sequence, it will be 1 plus 2 square plus etc. up to infinity. You can see that it is not a convergent sequence. Terms of 1 plus 2 square etc. up to infinity. It is not a convergent sequence when if r is greater than 1. Reason क्या है बेटे? As we move from left to right, term की जो value है बढ़ते जा रहे हैं, so it's a divergent sequence, it's not a convergent sequence. तो अब हमें discuss करना है this case, that is when r lies between, modulus r lies between 0 and 1. Again, I'll take one example. Let's take r to be 1 by 2 and a equal to 1. So the sequence will be 1, 1 by 2, 1 by 2 square, 1 by 2 cube, 1 by 2 power 4, etc. First term 1, second term 1 by 2, third term 1 by 2 square, 1 by 2 cube, etc. As we move from left to right, you can see that term की जो value वो कम होते जा रहे हैं, right? So can you tell me what happens to this sequence if n tends to infinity? Extreme right में जाके it will be 1 by 2 power n. As n tends to infinity, it will be 1 by 2 power n. Denominator 2, 2 power 2, 2 power 3, 2 power 4, etc. 2 power 100, 1000. It will be a very large number. So that 1 by a very large number is very small, negligible. We can take its value to be 0. Let us put the value here. As n tends to infinity, we get sum to infinity of a geometric series, a geometric progression. I'll denote it as S is equal to A into. I've explained it with an example. When r lies between 0, modulus of r lies between 0 and 1. We have taken an example. We have seen that r power n जो है, it will be very small, negligible. So we can write a into 0 divided by r minus 1, and the second term, it is independent of n, comes out to be a by r minus 1. So sum to infinity of a geometric series equal to, we can write a by 1 minus r. A by 1 minus r. Here remember, this is true only if 0 less than mod r less than 1. Or we say the series is convergent. Infinite GP is convergent only if depends on the value of r. Mod r should lie between 0 and 1. Only then the series is convergent. हमने example के through देखा भी है. Here the series, it will not approach to a single value, whereas here in the case S equal to a by 1 minus r is a convergent series. Let us proceed to the solved examples. First question, it's on the board. Given a, b, c are in arithmetic progression and a square, b square, c square are in GP, given a condition a plus b plus c equal to 3 by 2 where a, b, c are in arithmetic progression. So we can take a to be a minus lambda, b as a, c equal to a plus lambda. Put the values in the given condition. A plus b plus c equal to 3 by 2. A plus b plus c equal to 3 by 2 gives you 3a equal to 3 by 2 implies a equal to 1 by 2. So the numbers a, b, c can be written as 1 by 2 minus lambda, 1 by 2 and 1 by 2 plus lambda. We got these values by using the condition a plus b plus c equal to 3 by 2. See, one more condition is given. A square, b square and c square are in GP. A square 1 by 2 minus lambda square, b square 1 by 2 square and 1 by 2 plus lambda the whole square. These are in geometric progression. Three terms are in geometric progression. Apply the condition. What is the condition? B square equal to AC. Apply this condition. B square 1 by 2 square square equal to 1 by 2 minus lambda square into 1 by 2 plus lambda whole square. Simplifies to 1 by 16 equal to a minus b into a plus b. I can simplify it as a square minus b square whole square. 1 by 2 minus lambda into 1 by 2 plus lambda the whole square simplifies to 1 by 4 minus lambda square. Taking square root on both the sides, either it will be equal to 1 by 4 or 1 by 4 minus lambda square equal to minus 1 by 4. Two possibilities by taking square root. First one is rejected. Why it is being rejected? Because it gives you the value of lambda as 0. Read the question. A, B, C are in AP and A less than B less than C. So lambda cannot be 0. When lambda the common difference, if it is equal to 0, this condition will not be satisfied. So we reject this value of lambda. And second condition gives you 1 by 4 plus 1 by 4 equal to lambda square or lambda square equal to 1 by 2. I'll do the calculations here. Lambda equal to either 1 by root 2 or lambda equal to minus 1 by root 2. When you take the square root, two values are possible, of which first value we have rejected, and here lambda equal to 1 by root 2 or lambda equal to minus 1 by root 2, where lambda is the common difference of the arithmetic progression given. It is given A is less than B less than C. That means, what can you say about the sequence ABC? This sequence is an increasing sequence. ABC is an increasing sequence and you are getting two values for lambda, the common difference. One is positive and the other is negative. Since the sequence is increasing, batao bete, which value will take, positive one or negative one? Minus 1 by root 2 is being rejected. So the possible value of lambda is 1 by root 2. We need to find the value of A. A equal to A minus lambda, which is equal to A minus, the value is 1 by root 2, and A we have calculated to be 1 by 2. So 1 by 2 minus 1 by root 2 is the value of A if the sequence is an increasing sequence. See which option is matching. 1 by 2 minus 1 by root 2, that is option D. आगे बेटे समझ में? Suppose it is given, the condition given is A more than B more than C. बाकी सब same, only this condition. Instead of A less than B less than C, had the condition been A more than B more than C, what does it mean? The sequence ABC is a decreasing sequence. In that case, out of these two, बाकी सब same है, out of these two, which value you have to take? In this case, you have to take the value of lambda to be minus 1 by root 2. Sequence, arithmetic sequence is increasing if the common difference is greater than 0 and it is decreasing when the common difference is less than 0. आगे बेटे समझ में? Let us proceed to the next question. Question is written on the board. AN, a sequence series is given and one relation between AN and BN. Let us simplify. Let's put the formula here. AN equal to 3 by 4 minus 3 by 4 square plus etc. plus minus 1 power n minus 1 3 by 4 power n. It's a geometric progression whose first term is 3 by 4 and common ratio बताओ बेटे कितना है? Common ratio R equal to minus 3 by 4. Sum to n terms formula, sum to n terms equal to A R power n minus 1 divided by R minus 1, which I can rewrite as 1 minus R power n divided by 1 minus R. Let us put the formula A into 3 by 4, 1 minus R minus 3 by 4 power n, sum to n terms, divided by 1 minus of 3 by 4. 3 by 4 into 1 minus 3 by 4 power n divided by, this will be 7 by 4 equal to 3 by 7, 4 and 4 will cancel off, 1 minus 3 by 4 whole power n. This is our n. Second condition given, Bn is 1 minus n and Bn is greater than an. Bn is greater than an. Bn is given to be 1 minus an greater than an. What does it imply? This implies 1 is greater than twice of an. 1 is greater than twice of an. Let's do the calculations here. Or twice of an is less than 1. Twice of an less than 1. Put the value of an which we have calculated. Substitute the value. 2 into an is 3 by 7. 1 minus 3 by 4 power n less than 1. That is 1 minus 3 by 4 whole power n less than 7 by 6, or minus of minus 3 by 4 power n less than 1 by 6, which is minus 3 power n divided by 4 power n less than, I can write 6 as 2 into 3, cross multiplication is possible because 2, 3 positive, 4 power n, again it's a positive number, minus of minus 3 power n into 3 less than 4 can be written as 2 square power n divided by 2, which gives you minus 3 power n plus 1. Simplifying, numerator is 2 power 2n, denominator is 2. So we can write it as twice of 2n minus 1. What we have done, जो conditions दिए है उसको apply करके simplify करके, so we got an inequality which is minus 3 power n plus 1 less than twice of 2n minus 1. अब देखो what we have to calculate. हमें निकालना है the minimum natural number n naught such that this condition is true for all values of n greater than n naught. हमें ऐसे कोई n naught निकालना है such that this condition Bn greater than an is true for all values of n greater than n naught. Now we have two possibilities. Either n is even or n is odd. Let's discuss this case first. If n is even, n plus 1 will be an odd number. n plus 1 odd हो गया. So minus 1 power odd number, it will be a negative value less than 2 power 2n minus 1. It is of course a positive value. So if n is negative, we are getting the condition a negative number, negative value is less than positive value, which is true always. which is true always when n is even. Batao, what are the possible values of n? Natural number values 2, 4, 6, 8, 10, 12, etc. All these values are possible. Let us discuss the second case when n is odd. What are the natural number values possible? 1, 3, 5, 7, 9, 11, etc. Let us put n equal to 1. When you put n equal to 1, you will be getting minus 3 power n is 1, 1 plus 1, 2, less than 2 power n is 1 comes out to be 2 power 1. Is it true? Minus 3 the whole square less than 2. It is not true. Similarly, you put n equal to 3, 5, etc. आप अपने आप put करके देखो, you will get a statement like this, and the first possible value of n will be 7. 7 से लेके all odd natural numbers will satisfy this condition. So n can be 7, 9, 11, 13, etc. We need to calculate that n naught such that bn is greater than an for all values of n greater than n naught. अब आप बता सकते हो what is the smallest possible value of n naught? n equal to even के लिए 2, 6, 8, etc. Here 7 से लेके, so the smallest value of n such that the given condition is true is 6. 6 से लेके सारे numbers ले लो, n equal to 6, 7, 8, 9, 10, etc. For all natural numbers greater than or equal to 6, you can see that the given condition is true. So which option is correct? Option C. Clear? Let us proceed to the next question. Question is there on the board. A is the arithmetic mean of B and C. What do you mean by that? B, A, C, these are in arithmetic progression. Recall the definition. B, A, C are in arithmetic progression. Then we say A is the arithmetic mean of B and C. From here, what result we will get? Twice of A equal to B plus C. Let us call it as relation number 1. Second condition given. G1 and G2 are the two geometric means between the same numbers B and C. B और C के बीच में we have two geometric means, that is G1 and G2. G1 and G2 are the geometric means. So B, G1, G2 and C, they are in geometric progression. We have to calculate the value of G1 cube plus G2 cube. बेटे क्वेश्चन करने के दो तरीके हैं. Either you find G1 and G2. G1 and G2 निकाल के आप values डाल दो, और I'm going to explain in a simple way. B, G1, G2. B, G1 and G2, they are in geometric progression. Also, G1, G2 and C, they are also in geometric progression. A, B, C are in GP. A, B, C are in GP. Then B square equal to AC. Let us apply this result. B, G1, G2 are in geometric progression. What does it imply? G1 square equal to B into G2. Along with this, G1, G2, C are in GP. That means D2 square equal to G1 into C. G1 cube plus G2 cube. I am multiplying both the sides by G1 here. Why? Because I need G1 cube. Multiplying by G1, G1 cube equal to B, G1, G2. Also, G2 cube is required. So, multiplying by G2, G2 cube equal to G1C into G2. Adding these two relations, let's do the calculations here. We need G1 cube plus G2 cube, which is equal to B times G1 G2 plus C times G1 G2, from which I can take G1, G2 out. When you take G1, G2 out, what all things are left? First term B and second term C. See, what is our first equation? From equation number 1, what is the value of B plus C? B plus C is twice of A. Put this value here. So, G1 cube plus G2 cube equal to 2A into G1, G2. See which option is correct? 2A into G1, G2. Option B. Here, which property we have applied? If A, B, C are in GP, then B square equal to AC. If two geometric means are given, along with the geometric means, these numbers, two geometric means together with the given numbers, they are in geometric progression. We have grouped the terms, first 3 are in GP, second 3 are in GP. Apply this property, G1 cube and G2 cube are required. तो हमने जो relation मिला है उसमें first equation we have multiplied by G1 and second we have multiplied by G2, then added to get the required answer. Shall we proceed? Next question. You are given the value of one series, इसकी value निकालना है. Let us open the sigma, putting r equal to 1. What you will get? 1 by 1 square, r equal to 1, 2 minus 1, r equal to 2, 4 minus 1, 1 by 3 square, plus 1 by 5 square, plus etc. It is given to be pi square by 8. Let us call it as equation number 1. We need to calculate the value of sigma r equal to 1 to infinity of 1 by r square. I am going to denote this series as x. Put r equal to 1, 2, 3, etc. Batao, what's the series? 1 by 1 square plus 1 by 2 square, 1 by, I'll write 3, 4 terms so that you'll get the pattern. 3 square, 1 by 4 square plus 1 by 5 square plus 1 by 6 square plus etc. up to infinity. We need to calculate value of this series. 1 by 1 square, 3 square, 5 square etc. value is given. So collect these terms. 1 by 1 square plus 1 by 3 square plus 1 by 5 square plus etc. Collect these terms plus in second bracket all those terms which are left, 1 by 2 square, 1 by 4 square plus 1 by 6 square plus etc. up to infinity. X equal to, we are given its value, put the value, it is pi square by 8 plus. Can you tell me how do we simplify the second bracket? Terms dekho bete, the first one is 2 square, 2 can be written as 2 into 1 square. Second is 4 square, 4 can be written as 2 into 2 square. Third is 6 can be written as 2 into 3 whole square, etc. 2 into 1, 2 into 2, 2 into 3. Can you see a common factor there? In the bracket, 2 is common. That means when we take the terms outside the bracket, we will be getting 2 square. So I am taking 1 by 2 square out from the second bracket. Ye beta 2 we have taken out. We are left with 1 by 1 square, 1 by 2 square plus 1 by 3 square plus etc. up to infinity. Let's do the calculations here. We have now x equal to pi square by 8 plus 1 by 4 into. अब देखो what is the series? 1 by 1 square, 1 by 2 square, 1 by 3 square etc. This is our x. Put the value x. X minus 1 by 4x equal to pi square by 8. 3 by 4x equal to pi square by 8. Simplify it, cancels out, x equal to pi square divided by 3 2s are 6. What is our x? Nothing but the required series r equal to 1 to infinity of 1 by r square. It is pi square by 6. See, out of the given options, which one is true? Option C is matching. Clear, bete? Shall we proceed to the next one? Question number 5. Read the question. We are given sigma I equal to 1 to n minus 1 ai square x square plus twice sigma I equal to 1 to n minus 1 ai plus 1 into x plus sigma I equal to 2 to n of ai square less than or equal to 0. See, first sigma I varies from 1 to n minus 1. Second, again I varies from 1 to n minus 1. But the third one I equal to 2 to n. Let us simplify this term. Sigma I equal to 2 to n of ai square. Let us open the sigma I equal to 2 a2 square plus a3 square plus a4 square plus etc. plus an square. बाकी दो sigma I equal to 1 to n minus 1 थे, so I would like to write this sigma also from 1 to n minus 1. What I am trying to say is मुझे इसको ऐसे लिखना है I equal to 1 to n minus 1. Can you say what should be the suffix of a? a2 square plus a3 square plus a4 square plus etc. an square. I want to write it as I varies from 1 to n minus 1. For that, the suffix of a should be I plus 1. Values डाल के देखो. When I put I equal to 1, it is a2, I equal to 2, a3, etc. Last value I equal to n minus 1, it comes out to be an. Let us put the value here. So this inequation becomes sigma I equal to 1 to n minus 1 ai square. अब देखो बेटे, sigma variable is I, x is independent of this. So there is absolutely no problem. I can write it like this, ai square x square plus, same reason I am going to open it, sigma I equal to 1 to n minus 1 ai into ai plus 1 into x plus, this we have simplified. We can write it as I varies from 1 to n minus 1 of ai plus 1 the whole square is less than or equal to 0. अब देखो, each and every sigma, the variable I is varying from 1 to n minus 1. So we can rewrite this equation like this, sigma I equal to 1 to n minus 1 of ai square x square plus twice ai plus 1 x plus ai plus 1 square is less than or equal to 0. बता सकते हो what's the term inside the bracket? Sigma I equal to 1 to n minus 1 a square plus twice of ab plus b square. It is aix plus ai plus 1 the whole square less than or equal to 0. Let us do the calculations here. We have sigma I equal to 1 to n minus 1 aix plus ai plus 1 the whole square less than or equal to 0. On left hand side, how many terms are there? I varies from 1 to n minus 1. That means n minus 1 terms are there and each of them is positive. Why positive? Because of this perfect square. So on left hand side we have sum of n minus 1 positive terms less than or equal to 0. Sum of positive terms can never be less than 0. So from here we write sigma I equal to 1 to n minus 1 aix plus ai plus 1 the whole square is equal to 0 because less than 0 is not possible. Again, now we have on LHS sum of n minus 1 positive terms equal to 0. Sum of positive terms equal to 0, what does it imply? Each of them is 0 implies aix plus ai plus 1 equal to 0. From here we get aix equal to minus ai plus 1, which gives you ai plus 1 divided by ai equal to minus x. It is true for all values of I from 1 to n minus 1. Now, if you put I equal to 1, 2, 3, etc., what do we get? I equal to 1, we'll be getting a2 by a1 equal to minus x. Similarly, a3 by a2 equal to minus x, etc. What does it imply? The sequence a1, a2, etc. are in geometric progression. Then the sequence a1, a2, etc. are in GP. Which option is correct? Option A. Clear, bete? I hope you understood all the concepts and questions which you have discussed today. Practice them again. Do the questions given at the end of the module. Any problem, get back to us. Thank you.